Hi, and welcome to a brand new video. So today we're going to be tackling the problem on the screen. We first start off with a sorted array. So as you can see here, we have a sorted array, and it doesn't have to be like 1, 2, 3. As you can see here, 3 is missing, but then we're going to rotate it. And rotating basically means you push all the numbers to the right, and then the one at the end goes to the front. So as you can see here, this is an example of a rotated um, array. So with this rotated array, we need to find the minimum element inside the array. And it does specify to have an algorithm that runs in O log n time. So what we're going to try is I'm first going to show you something that would run in O one time, and then I will try out the O log n time. So let's get started. So the first method is to first sort the array and then return the sorted values. So that would just be arrays.sort nums and then return nums of 0. And then if you run it, as you can see, it turns out exactly like the notepad. But let's try the other method, which is trying to get in O log n time. So in that method, you would use the binary search algorithm. So what we can do is so first what we're going to want to do is get the base case out of the way. So the base case would be like, for example, the first element. So we would be if nums of 0 is greater than nums of nums.length minus 1. That means that it's not the shortest element, right? Because there's something, and because it would be either this or something else. So that's why. However, if nums of 0 is less than the final element, that means nums of 0 must be the element that we're looking at. So I'm just going to return nums of 0. Now we can start with the binary search algorithm. So we can be first we declare some variables, int left equals 0, right is equal to nums.length minus 1, and we do while left is less than right. We set mid equal to left plus right divided by 2, and we have two cases here. So what we can say is that if the two conditions is that we are at, either we have to move left or we need to move right. So first what you can do is you can say if nums of mid is greater than or equal to nums of 0, what this is essentially saying is if the middle element is greater than or equal to the first element. So if it is greater than or equal to, that means that it has a chance of being the answer. So what we can do is we can just move the left pointer here. And the reason that we're not like returning one of these values now is because we can actually just save a lot of time and return that in the end. So we can do else right is equal to mid. And right here, just remove this nums.length because if we're doing mid, then you don't need the minus 1 here. And then outside, we can just return nums of left. So what I did here was I said if if the current position you're at, so nums of mid is greater than or equal to nums of 0, then we want to move the left pointer. Otherwise, we want to move the right pointer. And eventually, you're going to move it until they're the same or one's like right between each other. So that's why we do this while left is less than right. And if it does match that condition, we can just exit and return left because left would be at the index that we were at. Also, just kind of as a failsafe, if left is equal to nums.length, just return nums of 0. That's kind of just as a safe to be like if that last element is the greatest that we're looking at, that means the first one must be the minimum. But right here, what we're doing is we're saying if it's greater than, we move the left pointer, and otherwise we move the right pointer. And eventually, we're trying to get to the least element, right? So we're trying to basically get right up till mid. So that's kind of how this works. So if you run it, you can see that we get the exact same answers. I also want to give one last method in if you want to try to solve this in a different way. So what you're going to want to do is we're going to first iterate through the we're going to iterate through the array. So we're going to be like for int I equals 1. We're going to be starting with 1 because if we start with 0 or the end of the array, we don't know which one, kind of which one's which at this point because it doesn't have, it's harder to, because you need to check the other one in order to see whether or not it's the minimum. So instead of doing that in this for loop, will just get a little crowded. We can do that at the outside the for loop. So that's why I'm going to start with 1. I'm going to go up to nums.length and I'm going to do I++. Now here what we can do is we can say, we can set, let's say, a boolean temp, and we're going to say if nums of I minus 1 is greater than i's of num of I and nums of I plus 1 is greater than nums of I, that means that nums of I is the minimum here. So basically, instead of setting a variable, we can also just put this directly in the if statement. We can say if this is true, return nums of I. Pretty straightforward. But what if it doesn't return? That means it's either the first element or the last element. So what we can do is we can just do a simple another if statement to see whether or not which one's the minimum. So we can say if nums of 0 is greater than nums of num dot length minus 1, then it's the last element. Otherwise, we return the first element. So what we're doing, just kind of as reviewing this method, is that we're saying if we iterate through that middle section of the array, if it is greater than the numbers around it, just return that number because that must be the minimum. Otherwise, check to see whether it's the first or last element. And as you can see, this also returns the right answers. So hopefully these 3 different methods were helpful, and see you in the next video.